Hello once again, welcome to Maths by Miss B. In this video we'll be looking at solving simultaneous equations. This is a second part to using the elimination method. In order to solve these simultaneous equations we need to get rid of one of the variables, either the a or the b in this case, in order to find the value of one of them. So here what we can do, let's just begin by labelling each equation, equation number 1, equation number 2. So what we can do is either decide to add the second equation to the first, so add the second equation to the first, or subtract the second equation away from the first, because either way it will get rid of either the a or the b. But in this case, if you look at the values or the coefficients of a, they're different. So by subtracting them we won't be able to get rid of them in this case, or even by adding them if they were negatives. And we can't get rid of the b's here just by simply adding them or subtracting them. So in this case we need to manipulate one of the equations. So what I can do here for the first equation, if I multiply the whole equation by 2, that will give me a 4a here, and then I can decide to subtract the second equation away from the first. Then it will be 4a, take away 4a will give us a 0 here at the bottom. So let's just begin by doing that. So I'm going to look at the first equation and I'm going to multiply it all by 2. So it's multiplying all three parts of it by 2. So equation number 1, multiply that by 2. So we get 2a times 2 will give 4a. 3b times 2 will give 6b. Then we've got an equal sign. 4 times 2 will give 8. Now the second equation stays the same, which is 4a plus 5b equals 10. Okay, so what we've really done here is created, let's say, a third equation. We'll just label it as equation number 3. Right, so now we've got 4a and we've got 4a here. Now we need to eliminate those, and the only way we can eliminate and turn them into a 0 is by subtracting, because 4a take away 4a will give us 0. But don't forget we've got to subtract all three parts. We're subtracting the second equation away from the first equation. Let's see what that leaves us with. So 4a take away 4a is 0a. Then we've got a positive 6b, take away a positive 5b. A positive and a negative here will give a negative. So 6b take away 5b will leave us with 1b. And then we've got 8 take away 10, and that gives a negative 2. So b is worth negative 2. So we have a value for one of the variables. Now what we can do is use that b equals negative 2 and substitute that into one of the top two equations. I'm going to go for the second equation because we've manipulated the first equation. Just in case there's a mistake, I will use the second equation. So the second equation is 4a plus 5b equals 10. So I'm going to substitute b equals negative 2 into equation number 2. Okay. Now equation number 2 is 4a plus 5b equals 10. I'm going to put the negative 2 into the b, so we have 4a plus 5 multiplied by a negative 2 equals 10. Okay, so just to simplify that down, 4a plus a negative 10, because 5 times negative 2 is a negative 10, is equal to 10. Plus and a minus gives a negative, so that's going to be 4a take away 10 is worth 10. Now in order to get the 4a on its own, we're going to add 10 to both sides, which will give 4a equals 20. So that's just adding 10 to both sides. And then divide both sides by 4 to get the letter a on its own. So 20 divided by 4 is 5. So we have a solution. A is worth 5 and B is worth a negative 2. Then what you can do is substitute this solution back in to one of the top two equations, and hopefully it should work and give you the answer, either 4 if you substitute it in the first equation, or a 10 if you substitute it into the second. Okay, so what I'm going to do, I'm very quickly going to substitute it into the first equation, where we have 2a plus 3b is equal to 4. So we have 2 times 5 plus 3 times a negative 2, and this should give me 4. So let's just move this one out the way. Okay, we can use that in a moment. So 2 times 5 is 10. 3 times a negative 2 is a negative 6. Plus and a minus gives a negative. So you end up doing 10 take away 6, and the answer is 4. So that's what we had in that first equation. So it clearly works. Okay, that was the first one. Let's just have a quick look at the second question. We have simultaneous equations here. We're going to start by labelling each equation as equation number 1 and equation number 2. The coefficients of x, I've got 2 here and I've got 3 here. They're clearly different. For the y's, I've got a positive 5 as a coefficient for the y and a negative 2 for the coefficient of y on the second equation. Now, if I manipulate one of these equations, it will still not match the second. So sometimes what you need to do is manipulate both of the equations. So I could, for example, decide to turn the y coefficients into 10, because I can find the lowest common multiple of 5 and 2, and that will be 10. So I can end up getting a 10y here and a 10y here. Then I can decide to add or subtract the two equations in order to eliminate them, because don't forget, the process is all about eliminating one in order to solve for the other variable. So I'm going to multiply the first equation by 2, and I'm going to multiply the second equation by 5. And let's see the result of that. So the first equation, multiply that by 2. So 2x times 2 will give 4x, plus 5y times 2 will give 10y, 8 times 2 will give 16. I can label this as equation number 3. Now, looking at equation number 2, I'm going to multiply all of that by 5. So 3 times 5 is 15x. Negative 2y times 5 is a negative 10y. And negative 7 times 5 is a negative 35. And we can label this as equation number 4. So we have 10y here and we have a 10y here. We need to be thinking about how we can get rid of those 10y's, excuse me. Right, the only way we can make those into a 0 is by adding, because if you think about it, I've got a positive 10y. If I add to it this negative 10y, add to it a negative 10y, the plus and a minus becomes a minus. 10y take away 10y will result in a 0, which is what we want, because this is a process of elimination. We've eliminated the y's, then we can begin to solve for x. Now, if I didn't do this and I decided to subtract instead, I would get 10y, take away a negative 10y, then the two negatives will become a positive. 10y plus 10y will give 20y. And this way I'm not getting rid of any of the y's. So that's the reason why we are deciding to add them instead. Okay, so by adding, don't forget we need to add all three parts. So 4x plus 15x will give 19x. 10y add a negative 10y will give 0y. 16 plus a negative 35. So you've got 16, add to it a negative 35. Don't forget, a plus and a minus makes a minus. So you end up doing this. So 16 take away 35 will give you a negative 19. Okay. Now if 19x is worth a negative 19, so let's just get rid of these y's now because we don't need them. So we can divide both sides by 19 because we're aiming to get the x on its own. That will give you x equals minus 1, because negative 19 divided by a positive 19 will give a negative 1. Now that we have the solution for the x, we can use that, substitute it in back into one of the first two equations to find out what the value of y is. So substitute x equals a negative 1 into, it doesn't matter which equation you pick, I'm just going to substitute it into equation number 1. So I'm just going to write out the equation number 1 again. Okay, that's 2x plus 5y equals 8. So I'm going to put the negative 1 into this x here. Okay, so we've got 2 multiplied by a negative 1 plus 5y equals 8. 2 times negative 1 is a negative 2 plus 5y equals 8. Let's get rid of the negative 2 from both sides in order to get the y on its own. And the way we can do that is add 2 to both sides. Remember to keep the balance. That will give y, 5y equals 10. And then divide both sides by 5. That will leave us with y equals 2. So we have x equals negative 1 and y equals 2. Now we need to make sure that we've got the correct solution here. What we can do is substitute it into one of the equations that we haven't used yet. So perhaps use the second equation. So where we have 3x minus 2y, we can substitute it in there very quickly to check to see it works and we haven't made any errors. So 3 times a negative 1 minus 2 times 2, does it give us a negative 7? So 3 times negative 1 is a negative 3. Take away from it 2 times 2, which is a 4. Negative 3, take away 4 does give negative 7. So it works nicely. Okay, I hope this did help. This was the second part of this elimination process. We will be looking at the substitution process as well in the later video. Thanks for joining me once again. Please remember to subscribe and hit the bell button so that you don't miss any new videos coming up. Thank you very much for joining once again. Bye for now.